Good evening, everyone. I am Mr. Ish. We have a very interesting question over here. The center of mass determination or the determination of centroid for the set of equations or functions that you see before you. F of x is equal to e to the x, y equals 0, x equals 0, x equals 1. The region bounded by those curves, we have to determine the center of mass for that. When you're graphing that, it's not hard. Y equals 0, your x-axis, x equals 0. Your y-axis, f of x is equal to e to the x, and then x is equal to 1. We're looking at all of this area right over here. That's exactly what we have. We have 0 here, we have 1 here, and this point right here will be 1 comma e to the 1. This right here will be 0 comma 1. You know the y-intercept for exponential functions is 0 comma 1. What is the center of mass or the centroid for this? You could visually estimate it somewhere right here, but it would be just an assumption. It could be inaccurate as well. We have to determine the exact. You know this specific point over here is in this form. You have an x and y coordinate representing that center of mass. And you know the formula is as such. You have 1 over a, the area of this. We'll determine that from 0 up to 1. You'll have x, f of x, dx. That's your this value. Your y value will be determined as 1 over a. Again from 0 to 1. You'll have f of x squared divided by 2 dx. That's the formula that will come through. Before anything, we have to determine this a. This a represents the area of this shaded region, area with regards to x. From 0 to 1, the top boundary curve is your exponential function minus your lower boundary curve is your x-axis, which is just 0, y equals 0 dx. You're basically just looking at this in terms of the antiderivative from 1 and 0. You have as the area coming out e minus e to the power 0, 1. E minus 1 is your area in all instances running through both of those equations. E minus 1, that's exactly what it'll be. And I will say that area is equal to e minus 1. Now we'll look at this x coordinate determination. We'll have 1 over e minus 1. From 0 to 1 we have x e to the x dx. You know this is integration by parts. You have to do it. U is equal to x, du is equal to dx, v is equal to integral of e to the x dx, which is e to the x. Then you do uv minus integral v du. You know when you do this, you're getting x e to the x minus integral of e to the x. The integral of e to the x is just e to the x. There's no plus c because we have definite integrals. All of this will shape out to be 1 over e minus 1. This is your area. And now your antiderivative is exactly what you see over here. X e to the x minus e to the x from 1 and 0. Upper limit, lower limit, not too bad. 1 over e minus 1, your area, as you see 1 over a. We'll put in the 1 values first. You'll have 1 e to the 1 minus e to the 1. And now we'll minus it from that. The lower limit, upper limit, lower limit, and the difference of the two, 0 times e to the 0 minus e to the 0. When you do look over here, this cancels out, this cancels out. The only thing which remains is minus e to the 0, which is really a minus 1, which in the presence of this becomes a plus 1. This plus 1 hits with this coefficient 1 over e minus 1. You're left with nothing but 1 over e minus 1. This 1 over e minus 1 represents your x coordinate. 1 over e minus 1, and we should save this value. I'll save this value right over here. X coordinate is 1 over e minus 1. Then at the end we'll marry it along with this y coordinate we're about to determine next. As you are seeing with this particular video, this is one step above the one you just saw before on the same topic where we were looking at the centroid determination for a triangle. See, this right here is a little bit more complicated simply because we have curved lines. This right here is the area which never changes. You have this 2. If you want, you can push out this 2. You don't have to. Anyhow, you're looking at 0, 1, f of x squared, which is e to the 2x over 2 dx. The antiderivative of e to the 2x is not hard. Antiderivatives of this exponential function are not hard in general. You're going to have this 2 right over here, 1 over 2. Then you'll have e to the 2x over 2. This is the antiderivative coming out just from e to the 2x, but this over 2 is right here on the side. And you know that, and then you're seeing this from 1 and 0. When you combine all of this, you really have 1 over 4, and then you have e minus 1 times this e to the 2x from 1 and 0. You can do the limit placement. You'll have e square minus e to the power 0, which is 1 over 4 parentheses e minus 1. You should open this up. You'll have e square minus 1 giving you e minus 1 times e plus 1. Then you have this denominator as is. These cancel out. You're left with just e plus 1 over 4. This represents your y value, the coordinate y value. And now you see how it came about. It's not anything other than just a definite integral procedure, but you have this 1 over area, 1 over a being combined with everything you see over here. So we've determined the y value, and I want to bring it now along with the x value. The centroid has been determined, the center of mass, which is the same thing, has been determined, and it is this. Your values are this, x and y are equal to exactly what I'll put, 1 over e minus 1 comma e plus 1 over 4. You can get a numerical value over here, and why don't we, just to get an indication of what it means. This is basically just calculator strokes, and you can do that. You have 0.581976 comma, and let's do the y value, 0.9295. That's exactly what it is. Somewhere past the half mark and somewhere higher than the 1 in terms of the y value is exactly where your centroid is for this particular graph, and the answer should be right. And that's all I wanted to present to you in this particular video. Determination of the center of mass of this region of space that you see over there between the curves and the lines that are present. And thank you for joining me for this video.